The Loch Ness Monster is believed by many people to be a persisting population, or at least a persisting individual plesiosaur, a marine reptile that is believed by paleontologists to have gone extinct around 66 million years ago, alongside the non-bird dinosaurs, when an asteroid collided with our planet, caused a lot of destruction, shut down photosynthesis, and really just it set forth a new path on this planet. This is a fossil of a nearly complete plesiosaur that was recovered in Germany 85 years ago. But it wasn't until 5 years ago that a team noticed something special about this plesiosaur. Near the tail was actually preserved skin, fossilized soft tissue. And by analyzing that soft tissue with a variety of high-tech tools, they were able to see the skin and this exterior look of a plesiosaur in higher detail than anyone ever had before. Based on their observations, especially these folds in the skin you can see right here, they concluded that the tail was likely covered in fleshy skin somewhat similar to that of a sea turtle's. But there was actually some soft tissue recovered from one of the flippers, and instead of that fleshy skin, what they found was scales. Plesiosaurs were a very diverse group of animals. Like I said earlier, they lived for nearly 150 million years, so there were thousands and thousands of species, some really big, some really small. What this new evidence shows us is that at least some of those plesiosaurs had a mosaic, a blend of traits, skin, and scales like we see in modern turtles. The researchers hypothesized that this smooth skin covering the animal may have helped make it more streamlined, make it faster moving through the water, and then the scales on the flippers could have actually provided some extra toughness as they were moving, maybe near the bottom, chasing their prey. Speaking of prey, there was actually some prey preserved in the gut of this plesiosaur, some little shelled invertebrates, showing that this plesiosaur, it wasn't just eating large animals, it was eating little shelled animals. Now, I talked about this find on my TikTok last week, and I had dozens, hundreds, safe to say hundreds of comments of people saying that this must mean this animal wasn't actually 183 million years old, because there's no way this soft tissue could persist. That's not true. We've learned a lot about the preservation of soft tissue. Fossilization of soft tissue isn't nearly as rare as we once thought, but that's the cool thing about science. We're always learning. We don't stick to old ideas. Instead, as new evidence is uncovered, we work to understand it. The history of our species has long been intertwined with wolves, and it's been a really hot and cold relationship. Some wolves, they protect us, they live alongside us, they're our greatest companions. Some wolves historically have hunted us. However, for most of us, our natural environment today is not very similar to that natural environment where people were actually having to deal with wolves in that way. Think about France hundreds of years ago, like that's a different time. But unfortunately, those stories, those memories, that fear, it persists, and it makes it really tough for us to live alongside these predators. In fact, this is one of the things that led to the loss of the thylacine, the Tasmanian tiger, because people coming from not Tasmania that had been dealing with wolves, they got to Tasmania, they wanted to keep their sheep there, and they just assumed that the Tasmanian tiger was something that was going to take all of their sheep and be a big problem for them. More recent studies have suggested that a Tasmanian tiger, based on its jaws, probably couldn't have actually been taking down sheep. But anyways, the reality is we need to learn to live alongside predators. We can't just wipe out an apex predator because we're scared of it or because it may hunt some of our livestock. We've got to find a better path moving forward. And that's why studies like this new one on Yellowstone are so important, quantifying the actual impact of returning wolves to ecosystems. This specific paper was looking at the relationship between the reintroduction of wolves in 1995 to the recovery of willow trees, two organisms that you wouldn't really expect rely too much on each other.
Hearing a lot about next year is the wolf in the West. That's the reintroduction of wolves into Yellowstone National Park.
Some quick history here, and I know this is one of those cases that we talk about a lot because it's such a great case showing why apex predators are important for ecosystems. But back in the day, they basically wiped out most of the cougars, the grizzly bears, the gray wolves, and certain pockets have allowed for recoveries over time. But we have actually been able to study the recovery within Yellowstone, where those large predators were pretty much exterminated 100 years ago. The loss of those predators had other effects downstream in the ecosystem. Elk no longer had to worry about the predators, so they were able to just graze near the streams as much as they wanted. That led to erosion within the streams. Beavers eventually just left the area because the environment was no longer one they could really thrive in. And it's really just a great case study of how removing the predators led to effects with animals like beavers, birds, and willow trees. Not even animals, but plants. It's one of those cycles that just spins out of control until eventually the government is having to kill elk because the wolves aren't there to do it. So back to this experiment. In 2001, a team of researchers from Colorado State University sectioned off some plots of land within Yellowstone. Some sections were pretty much just left untouched as control groups, while other sections had fences put up to make it so elk and those herbivores that the wolves had been keeping in check, they couldn't get in there and overgraze, and they wanted to see what would happen with the willow trees. But then there was another variable they changed, and this is where things get interesting, because in some of these plots, they put simulated beaver dams. Now that all this time has passed, they've been able to go back and look to see what happened in this specific study. They were quantifying the willows based on like the 3D, how much space they took up. And what they found is that simply fencing off the areas, it really didn't lead to much of an impact with those willow trees. You would assume that once those herbivores aren't allowed in there, you're going to see the willow trees recover, they're going to get tall again. It's not what happened. But with the plots that had fences and also had the simulated beaver dams, what happened is that those beaver dams, they raised the water table enough that it actually had a profound impact on those willow trees. So why is this extra layer of complexity, this extra variable so important? It shows that the recovery of an ecosystem isn't always as simple as just taking that apex predator and putting it back. That's not always enough. And the longer that apex predator is gone, if we actually let them go completely extinct locally, the longer that happens, the less likely the recovery of that ecosystem will be. Yellowstone National Park senior wildlife biologist Daniel Stoller had this to say. This long-term research conducted by the CSU team also highlights the value of national parks in helping us understand ecological processes in order to better protect ecosystems. We should not only cherish our national parks because they protect, preserve, and allow people to enjoy nature, but because they provide a place where well-designed science can elevate our understanding of its complexity. This experiment was actually inspired by a researcher that was watching a duck that would just let itself float down the stream, and then it would fly back to where it started and float back down the stream again. That same researcher was later at a symposium where researchers were discussing whether insects could actually make intentional decisions. In an attempt to answer that question, this team set up an arena, and in that arena, one fruit fly would live for 3 to 4 days on average. In the arena was food and water, but there was also a carousel, and the carousel would spin. While the fruit flies were in the arena, they were being recorded, and that recording was then monitored and analyzed. They went through over 7 days of data, so you can imagine they were using quite a bit of technology to assist with this tracking of the flies. But what they actually found was interesting. There was a large population of fruit flies that they called the avoiders. And these fruit flies, they weren't interested in the carousel at all. They would actively try to avoid it. There was also a big population that I'll consider the meh population. They really didn't care. If they ended up on the carousel, whatever, they'd probably hop off, but wasn't that big of a deal. But then there was a small population, and this population they called the seekers. The researchers compared it to a playground where not every kid is going to act the same. Some are going to be way more enthusiastic and be just jumping at the opportunity to play. Others are going to hang back. So that's what seems to have been mirrored with this fly population. But then they took it even further. And for me, it honestly really solidified that this seems to be showing that the flies are playing, at least if we consider a kid going to a swing and sitting on that swing and swinging back and forth playing. What they did is they created a similar arena, but this arena had 2 carousels, and only one carousel would spin at a time. So one would spin for 5 minutes, and then it would stop, and the next one would spin for 5 minutes. And in those seekers, a lot of those seekers would go to a carousel, they would spin until it finished, and then they would hop off and hop on the next carousel, and spin on that one. So again, if we consider swinging on a swing playing, this seems to be showing that fruit flies like to play. So next time you're sitting in the classroom or sitting on your couch and you see a fruit fly, I don't know, maybe this study will make you think about the world a little bit differently. To wrap it up, we have a behavior that was observed and published that had never been observed in a non-primate animal before. Previously, it had only been humans and then the Japanese macaque. And that behavior is dunking food in something else to flavor it. What's unique about the Japanese macaque and these birds is that with the monkeys, they initially started by dunking the potatoes in fresh water, kind of to wash them off. They eventually started doing it in salt water, and the salt water seemed to become their favorite, so they think that was because of the taste it added. But with these birds, they actually noticed that they would take noodles, and they would take the noodles to the blueberry yogurt, they would dunk the noodles in the blueberry yogurt and then eat it. To test whether they were truly flavoring it, they set up an experiment, and they gave them a variety of different things they could use as their main food source and a variety of things they could dunk it in. Not only did they have the blueberry yogurt, they also had a more neutral flavored yogurt. So that was their way of testing whether it was truly the flavor. And sure enough, with these birds, the evidence suggested that some of them, they did prefer the blueberry yogurt and they were flavoring their noodles. So again, I posted a TikTok about this week. Lots of people in the comment section were saying that their birds also do this. Again, this is one of those things where I think for a long time, we have just underappreciated animals, and we are now starting to realize that a lot of the stuff we thought was human specific, it seems to be more common in the animal kingdom, like the play with those flies. Thanks for watching. I'm enjoying making these. If you want to support and help ensure that I can continue making these weekly and potentially even 2 a week during the summer, which is something I'm thinking about, I'll link my Patreon. I'll link my Venmo. I really appreciate everybody that has helped so far, and I hope to continue being able to bring science news to you for years to come.